Welcome to today's webinar on TotalCAE and AWS Cloud Training Series, Buying Cloud Hardware for CAE. Now, if you're not familiar with TotalCAE, a little bit about us. We help engineering clients take simulation runtimes that might take weeks or days and get that down to hours. And we do that with managed high-performance compute clusters and public cloud that we then support hundreds of different engineering applications through our simple-to-use web portal that lets you run all these apps in just a few clicks on clusters and cloud so that you could just focus on engineering and not worry about IT complexity. So a little bit about buying cloud hardware. Now, buying managed clusters is pretty easy. You can pay a monthly fee, month to month for 36 months, for example, as a lease, or you could just buy it outright. But when you're buying cloud hardware, there's a lot of different flexible options that we're going to cover kind of today. So you'll pick the kind of hardware you want, and then you can apply the kind of plan to acquire that hardware that you'd like to do. And when I say hardware, I might also use the word instances. You can just consider those kind of the same equivalent thing. So the first kind is on-demand instances. Those are kind of pay-as-you-go. You submit your job then runs on nodes. Those nodes will power on. Once your job's complete, the nodes power off. There's another kind of way to buy compute times called reserved instances. And that's kind of more analogous to on-prem clusters, where you'll buy it for 1 year or 3 years, and then you can basically have that machine. It's always on. You pay for whether you use it or not. But that, if you use enough compute time, that will save you overpaying for the equivalent on demand, 30 to 60%. Now, there's also savings plans, which are more flexible than reserved instances and let you, pick and choose your hardware, region, operating system, other things, similar kind of savings. And then finally, you have spot instances, which let you pay a lower price than on demand for unused capacity in AWS. You could save anywhere from 30 to 90%, just depending on the type of instance you have. So let's just start with on-demand. On-demand is what everybody kind of has into their mind when they first think about cloud. It's pay-as-you-go computing. When you submit your job, your simulation, the nodes will turn on, the billing will start, your job will crunch, and once it completes, the answer is returned, the nodes turn off, and the billing stops. There's no minimums. You could basically have no commitment. And so this is really good for burst workloads, where you have overflow possibly from on-premise. You want to pay to not queue, or maybe you have, various types of jobs that you are only running on occasion. So the downside of on-demand capacity is not always available. So it's not guaranteed, just like a light switch is, that when you flip the switch that suddenly the compute power will be there. Occasionally, basic cloud computing is just a computer in someone else's data center at the most basic fundamental level. And so even AWS has finite capacity for some types of machines in certain data centers. So if that happens to you, there's various options. You could try different AZs, you could try different regions, you could do capacity reservations, or you can buy reserved instances. And so, that doesn't happen very often. It's just good to know it happens. Now, running on-demand instances on TotalCAE is super easy. All you do is pick the kind of computer that you want. The C5 18 extra large is like a name of the computer, which we'll learn a little bit later. That tells you that we have a curated list per application of the instances that will run best for your machine, that have certain amounts of memory, compute, GPUs, and so on. So just realize to run on that hardware, you just pick it and push a button. It's really quite simple. We'll take care of all the details of getting the machines to turn on, and then running your job, and then worrying about turning it off, and all you have to do is focus on engineering and getting your model to solve. So what you'll see when you submit on our status page, you'll see the machines waiting for workload. Once you have a sufficient CAE licensing and there is capacity in AWS, the machines will boot up, and then we'll run your job, and then they'll be allocated. So the next kind of type of way you can buy these machines is called reserved instances. And so you can buy all kinds of different machines with these reserved instances. And this kind of construct is, like I mentioned before, similar to on-prem. You're buying a thing like a C5N computer for a fixed period of time, 1 year or 3 years, and you pay whether you use it or not. So this is kind of a good model if you need guaranteed availability, because when you turn it on, it's yours to keep. It is not going to disappear on you. There's not a way for it to suddenly be unavailable to you. under normal operating conditions. The other nice thing is, unlike in the on-demand case where you submit your job, you have to wait a few minutes for the nodes to boot. Well, these are always on. You don't have to wait for boot. It's also the lowest cost for sustained usage. So if you're using, let's say, for 8 months, or quite a heavy simulation, even though you're paying, if with a reserved instance, for the 4 months you might be using, it's still way cheaper than paying on demand for 8 months long, 24 hours a day. And so you'll find that reserved instances are a good way to lower your cost for fixed compute capacity, your steady state, your simulations you do every day, and you kind of know what that baseline looks like. And so running on reserved instances on TotalCAE portal is very super easy. Just pick a reserved instance. It's always on. It'll instantly run your job as long as you have sufficient CAE licensing. And finally, I should mention there is also, we talked about savings plans. Savings plans is a type of variation of a reserved instance, way more flexible. You can choose different kinds of computers, different regions. You can mix and match types of OSs and so on and so forth. So it's just a more common way these days that came after reserved instances that most customers are using to have more flexibility but reduce cost. And you submit it the exact same way you do with reserved instances. So the final kind of option is spot instances. And what spot instances are is if AWS has idle capacity, you can make a proposal to run on that idle capacity for a vastly reduced price. And so you could basically submit a job and it runs just like on demand, but at a reduced price. So in this case, you could see if the on demand price is $306, if you submit your spot job, you could pay as little as $1.16 in this particular availability zone, or anywhere in between that range. So it's just a way to save money. So you might ask, well, why wouldn't I always just submit to spot then? Well, there's a couple reasons. One is there's no guarantee that spot, the AWS is going to have idle capacity. So you may be waiting a while from when you submit for your job to start. The other reason is once it does start, your job could be killed. And if you look on AWS website, for each kind of machine type, they give you a probability that it could be interrupted. And that is, on this machine here, it's 5% chance. So every 100 jobs you submit, maybe 5, you might get 5 that get interrupted, for example, if all things being equal. So if you don't want your job, have 0 chance for your job to be killed, then you could go to on-demand or one of the other options. Now, I should say if your job is less than 6 hours or less, you can submit a special type of request to Spot saying, hey, if you accept my job, do not kill it, and they will guarantee if it's 1 to 6 hours that they will not kill that job if they accept it. Now realize that does reduce the odds of you being accepted with that kind of option, but it is nice for short-running jobs to make sure that they don't get killed. So again, spot instances based on their nature are really good for non-urgent short-running jobs. If you run less than 6 hours and you could wait, 8 to 10 or 2 days or however long it is for the spot price to be accepted, then that's great. You save some money, you can get that workload ran. Now, if it's a job you need absolutely no later than the next 4 hours, well then maybe not your best option. It's also good for workloads that can be checkpointed. Not all CAE applications can be checkpointed, but some like StarCCM Plus, Converge, a lot of CFD solvers can checkpoint. And if you do checkpointing, then if your job is killed, at least you didn't lose all of that work up to that point. It's also good for design of experiments, which by their nature, you run a whole bunch of jobs. You're searching the design space. Maybe every particular job isn't super important if a couple get killed, nor is it super urgent to have it by morning to make a particular design decision if you're searching for some type of optimization. So though it could be good for that. And if you're super price sensitive, then it is the cheapest option if that is your main goal to optimize. Now, running on Spot on TotalCAE is quite straightforward. Again, you just pick Spot. So Spot C518 extra large will pick that version of a Spot instance. We have a kind of unique feature that says, hey, I am not willing to wait forever for my Spot request to be fulfilled. So if for some reason after so many hours I cannot get it fulfilled, fall back to on-demand in hopes to get an on-demand instance instead of just waiting for Spot. Then if you also want to make sure your job isn't killed, you can just choose a time limit, 1 to 6 hours in our portal. We'll automatically set that spot block duration for you, and that will make sure if your job is fulfilled, it is not going to be killed as long as it runs less than 6 hours. So in the CAE status window, you're going to see it waiting for workload. Once you submit spot, we'll start asking AWS for that capacity, see if we have some spare idle capacity that they will give us. And then your job will either be allocated, or if we get to the fallback to on-demand time, it'll fall back to on-demand. Now, a couple other things you might be aware of when you're looking at pricing on AWS Compute is notice that the vCPUs are hyper-threaded CPUs, which means they're not a full core. Because CAE licensing is licensed by true cores, we always disable hyper-threading on-premise or cloud systems. And so just divide that by 2, you're getting 36 actual CPU cores when you're running on those instances. And like I alluded to before, these names of the compute hardware like C5N 18 extra large, they have meaning, and these letters and numbers mean something. And so this is kind of like a decoder ring to help you determine like what's going on when you're looking at these names. You can certainly look in a console and get the details, but it'll tell you the instance family, what generation of the instances is. The next letter tells you if it has any additional capabilities like elastic fabric adapter, which can be used for tightly coupled scale-out workloads. And then you get the kind of machine it is, which tells you how many CPUs and so on and so forth that this instance or computer has. So we've already curated the best ones for you in the portal, but these have a nice, they have meaning and description of what those actually are, and we can alias those for you if you want to have a more human readable name that means something to you. One other item to note is that just because a instance has a cheap core hour price does not mean that will translate to your cheapest job cost. In fact, we've seen many times where a particular instance will have a 50% core hour difference. It'll look substantially cheaper, but when you actually run your job, the job is more expensive when you include the fact that maybe it will run faster, consume less CAE license therefore, and so the overall job cost will be much cheaper than just the cheapest instance that you can find. So just be aware that is why TotalCAE's billing reports are all done by job. We will give you, like in this Excel report, the cost of each job. We calculate the estimated job cost before you submit, and then we will tell you the actual job, every job you've submitted, what it actually cost you. So you'll have a kind of a feeling of what your actual job costs, and then use that to baseline your simulation budget, and not just look at per core hour rates, which don't really tell you anything about how much simulation is going to cost you. So now, to kind of show you how easy it is to use TotalCAE and AWS, I'm going to show a short demo video that's going to highlight submitting these different kinds of workloads using Abacus, and you'll kind of see then what's involved and how easy it is used in just a few clicks to get your jobs running. When you first log into the TotalCAE portal, you're going to see a list of the applications assigned to your company on the left-hand side. Here, I'm going to choose Abacus. So now I have 3 steps. I'm going to choose my model, I'm going to choose the number of cores, and then I'm going to push the submit button, and that will send it to the cloud for solving. So here I'll just go ahead and pick this S4B model. I will choose 8 cores, and then I push submit. And that's pretty much it. The job has now been submitted to the cloud and will solve. I chose to solve this model on a reserved instance. A reserved instance is a kind of computer on the cloud that you've prepaid for up for 1 or 3 years and is always left on. In this case, this normal reserved C518 extra large is costing $193 per hour, and this job could cost me an unlimited amount of cost because I've chosen not to cap the runtime. I want it to keep running no matter what. I'll monitor it to make sure it doesn't exceed what I would hope to spend. Now if I click on list jobs, I can see my job is running here. I could go ahead and download the STA file, ODB file, any type of output from this particular solver application. And now I can go to the status page and I can look at the visual representation of the job queue. I can see that my reserved instance node 5 is running this job right now. I can see how much licensing, CAE application licensing my job is using, how much is pending, and I can see the kinds of available limits I have for various types of compute hardware in this account. Now let's look at how to submit that exact same job, but this time to an on-demand queue. What on-demand is going to let us do is when we submit, the node will power on, and then it will run the job and it will power off, and we'll pay for that time that we used while the machine was running our calculation. So to do that, all I have to do is go to this drop down and choose to run on C518 extra large. That is the kind of computer hardware I've chosen. And then I'm going to cap it this time to just 2 hours. You know, I don't really want to spend more than $6.12 on this job. So if it doesn't solve or doesn't converge properly, has any type of issue or runs way longer than I thought, cap and kill this simulation if it runs more than $6.12 or 2 hours. So I'll go ahead and push the submit button, and that's it. Now I'm running in an on-demand fashion using the same model and the same workflow. Now I can go ahead and I can look here at my job, and I'm going to see it's in the configuring state, and it is waiting for this machine that's been allocated N007 to boot up and be turned on. So we'll go to the status page and we'll get a little bit of visual feedback. We see node 007 here is powering on. Once the machine powers on, it will go ahead and run our job, run the calculation, then turn back off and be waiting for more additional workload. Now you can see the machine has been allocated. I did some magic fast forward so we wouldn't have to wait the couple minutes it takes for the node to boot. But now you see it's allocated and it's going to be running our job. And again, we can download the results from our simulation on the list jobs page here. And when the job is completed running, then we can go ahead and download those results, and the machine will turn off and the billing will stop. So now we're going to try and submit to a spot instance. What spot computing is it's kind of like how an airline prices empty airline seats. If there's available capacity, they might give you a cheaper rate to keep everything full than just let those seats go empty, for example. So now what will happen when we choose to a spot computing, we'll get a much cheaper rate. So here we are at C518 extra large at $3.06 per hour on demand. Now if I pick spot, you know, it drops down to $1.56. That's nearly over a 50% savings nearly. That's pretty good. Now you might ask, why doesn't everybody submit to spot? Well, the downside is that they may not have free capacity. They may have free capacity and not willing to give it to you at this current spot rate. And if your spot price is accepted, then it could be killed unless you choose to have a 1 or 6 hour spot limit, which will then be a little bit more money, but make sure it doesn't get killed. Now again, to all of this kind of is automatic. We've already pre-optimized what the bidding price should be based on our analysis of these types for the last months to get them running. And you can do limit. If you do a 1 hour limit, you notice it is a little bit more money, and as you go up in time, up to a maximum of 6 hours, you get a guarantee that if they fulfill your job, it won't be killed. So if I submitted this, I could guarantee that it would not be killed for 6 hours, and the maximum job cost would be $15.48. That being said, is that you have a less chance for your spot bid to be accepted when you have limits like this. If you have a better chance for them to accept and run your job if there are no time limits. The downside being it could be killed at any time. So again, the advantages and the kinds of CAE workloads that are good for this: ones that you don't need immediate answers for, because it might take a while for the spot price to be accepted and to have the compute cycles available, and or jobs you could checkpoint often, or you don't mind being killed, that run over 6 hours, or jobs that can fit under that 6 hour window that are urgent. Those are all kind of good capability. Now, let's say you want to get the job in the morning, but you want to have a chance to get it kind of a cheaper rate. You can do a unique feature we have. It's called fallback to on-demand. So I could say, I am willing for about 10 hours to wait for this to start, hope to get a cheaper price, get my savings. But if for some reason after 10 hours, I still have not gotten the cheap rate, go ahead and fall back to on demand and then pay the normal price. So the only thing I had to do really to choose spot was choose this button. It gives me a reminder about the delayed interrupt start, and then I decided to do a fallback of 10 hours that I want to go because I want to have it by morning, and it's takes a couple hours to run. So let me just have a 10-hour run. I just push the button, and that's it. So we go to this tab and I can see that my node 34, is being configured for spot computing. And I look here and I can see that node 34 is looking for capacity to power on. So in the background, we are trying to get the spot computing price and get that hardware for you. And we're going to wait for up to that 10-hour mark to decide to then flip it back to on demand if it hasn't ran. So we'll just wait here and see if we can get some capacity. All right, now I fast forwarded through some magical time travel here. It took about 4 minutes in real time for the capacity to be decided to give to us, but now we've been allocated our job. We are getting that on a spot node and it's running just like it would have, and now we're getting to run that at a reduced rate of the spot price.